everyone, welcome to another class of statistics for engineers 2. So previously we have already discussed the scatter diagram, correlation, and linear regression. So in this video we will discuss about the multiple correlation and multiple regression. So when we say multiple correlation, it is a statistical tool that allows you to examine how multiple independent variables are related to a dependent variable. So the formula for R, or for the multiple correlation coefficient, is this: the square root of R sub yx1 squared plus ryx2 squared minus 2ryx1 times ryx2 times r sub x1 x2 all over 1 minus r sub x1 x2 squared, where the r sub yx1 is equal to the correlation coefficient for y and x1. Okay, so you'll have to take a look of the subscript. For r sub yx2, of course, that is the correlation coefficient for y and x2, and for r sub x1, x2, that is the correlation coefficient for x1 and x2. So this is the formula that we will use if we will compute for the multiple correlation coefficient, and that is denoted by capital R. Now, when we say multiple regression, it generally explains the relationship, okay, between the multiple independent or predictor variables and one dependent or criterion variable. So this multiple independent or predictor variables, this is denoted by X variables, and the dependent or a criterion variable is denoted by the variable y. So a dependent variable is modeled as a function of several independent variables with corresponding coefficients, along with the constant term. So multiple regression requires two or more predictor variables, and this is why it is called multiple regression. Now this is the formula if we will try to compute for the y hat. So y hat is the predicted values of y, and that is equal to a plus b1 x sub 1 plus b sub 2 x sub 2. So to solve for b sub 1, b sub 2, and a, we have here the formulas. B sub 1 is equal to rx sub 1 y minus x sub 2 y times rx sub 1 x sub 2 all over 1 minus rx sub 1 x sub 2 squared, and multiplied by the sample standard deviation for y over the sample standard deviation of x sub 1. Now for b sub 2, okay, so that is rx sub 2y minus rx sub 1y times rx sub 1 x sub 2 all over 1 minus rx sub 1 x sub 2 squared. Then multiplied by the sample standard deviation of y all over the sample standard deviation of x sub 2. And for the value of a, so that is equal to y bar, or the mean or the average of y, minus b sub 1 times x sub 1 minus b sub 2 times x sub 2. So in order for us to fully understand the multiple regression, let's apply that here in this example. So the data comes from a cargo ship. So our x1, this one, is the weight of the product loaded on the cargo vessel. So this one, so this column is for the x1, that is weight times 1,000 pounds. And x2 shows the distance traveled by the ship. So this column is for the distance times 1,000 meter, so this data. Then y shows the cost in dollars. Now we are asked to determine the multiple correlation of the data and regression analysis. Also, if x sub 1 is equal to 2,400 pounds and x sub 2 is 1,200 miles, what will be the cost? Okay, so in this table, we have here x sub 1 minus x sub 1 bar, x sub 2 minus x sub 2 bar, y minus y bar, x sub 1 minus x sub 1 bar squared, then square root of x sub 2 minus x sub 2 squared, then square root of y minus y bar, then the product of this column, x sub 1 minus x sub 1 bar and y minus y bar, then the product of x sub 2 minus x sub 2 bar and the y minus y bar. Also the product of these two. Now um, let us start our computation. So for x sub 1 minus x sub 1 bar, I so here I already computed for the x sub 1 bar, that is the average of this data. So 4 plus 3 plus 1.6 plus 1.2 plus 3.4 plus 4.8. So the average of these values is 3.000. So I used 4 decimal places. Then for x sub 2, the average is 1.5167. And for the average of y, we have 123.3333. Okay, so to solve for the x sub 1 minus x sub 1 bar, okay, so let's just consider the first column. So 4 minus the average 3, that is equal to 1. Then 3 minus 3, 0. 1.6 minus 3, negative 1.4. 1.2 minus 3, negative 1.8. 3.4 minus 3, 0.4. Then 4.8 minus 3, we have 1.8. Then same with the x sub 2 minus x sub 2 bar. So let's just consider the second column and the average, the x sub 2 bar. So 1.5 minus 1.5167. And so I use 4 decimal places. Then repeat for other values. Then for y minus y bar, same process. So that is 160 minus 123.3333. I have 36.6667. So this is rounded. Okay, that's why it is 6667. Then repeat the process for other values. Yan. Then for this one, so the square of x sub 1 minus x sub 1 bar. So let's just square this column. So 1 square is 1, then 0. Yan. So this is the square of these values. Then square of x sub 2 minus x sub 2 bar. So we will consider this column, then square them. We'll have this one. So yan, 0.6833 squared, 0.4669. Then repeat those. Yan. For y minus y bar, so squared. Yeah, we'll have these values. You can try and check by yourself so as to practice also. Then for x sub 1 minus x sub 1 bar, okay, you will multiply this and this column. Okay, so 1 times 36.6667. And then repeat for other values. So doing multiple regression takes a little bit of your patience. Then for x sub 2 minus x sub 2 bar, so this column and this column. Ayan. So these are the values that we will get. Then lastly, the product of x sub 1 minus x sub 1 bar and x sub 2 minus x sub 2 bar. Yan. Then after that, we'll get the summation of these columns. Okay? Summation. Okay, so these are the sum of these columns. Now let's proceed with the computation of. So our formula for Rx sub 1y is equal to the summation of x sub 1 minus x sub 1 bar times y minus y bar all over the summation of these two variables. Okay, so x sub 1 minus x sub 1 bar squared times the summation of the square of y minus y bar. So substituting the values that we got from the table, We have 285.4000 all over the square root of 9.6 times 9463.3333. Okay. So, yan, we'll have 0.9469. Then, for Rx sub 2y, okay, so in order for you not to be confused when computing, so you just have to consider or take a look with the subscript. So we have x sub 2 here. So all your variables should be in x sub 2 and y. Okay, so this one is in y. Then substitute the values that we got from the table. We'll have 0.0764. Then for x sub 1, Rx sub 1, Rx sub 2. Okay, this is in terms of x sub 1 and x sub 2. Okay, so we have negative 0.0794. Now we have to solve for the multiple correlation, that is the capital R. Okay, so substitute the values that we got from the previous slide. Yan, we have the square root of 0.9469 squared plus 0.0764 squared minus 2 times 0.9469. Ayan. So, we'll have the answer as 0.9590 or equal to 0.96. And it means very high or strong positive correlation. Now, we have another, we have another question. So, estimate the cost when a shipment weighing 2,400 pounds is moved to 1,200 miles. So, this is a follow-up question. So, to find the estimated cost, first we need the standard deviation of each variable. So, for S, x sub 1, and so we'll just have to substitute the summation of x sub 1 minus x sub 1 squared all over n minus 1. So we'll have 1.3856. For the sample standard deviation of x sub 2, we'll have 0.5456. Then for sample standard deviation of y, we will have 43.5048. Okay. Then to solve for the values of b and a, okay, so these are the formulas that we have introduced. So B1 equal to Rx1y minus Rx2y times Rx1x2 all over 1 minus square of Rx1x2 times the sample standard deviation that we got a while ago, Sy all over Sx1. So just substitute the values. We'll have 30.1109. Then for B2, so almost the same formula. Okay, so B2, so this will be x sub 2y and x sub 1y, x sub 1, x sub 2. Then for sample standard deviation, this should be Sx2. Then we will have 12.1636. Then for A, so that is equal to y bar minus b1 x sub 1 bar minus b sub 2 x sub 2 bar. So that is equal to 14.5521. So now that we got the B1, B2, and A, we'll proceed with the estimated cost. So note that the data provided in the table shows times 1,000 in weight and distance. Therefore, since we're given 2,400 pounds and 1,200 miles, so 2,400 pounds will be 2.4 and 1,200 miles will be 1.2. So at x sub 1 is equal to 2.4 and x sub 2 is equal to 1.2. So from our multiple regression equation, that is y hat is equal to a plus b sub 1 x sub 1 plus b sub 2 x sub 2. That is equal to 14.5521 plus 30.1109 times 2.4 plus 12.1636 times 1.2. Our y hat will be equal to 101.41. So in conclusion, the cost when we have 2,400 pounds be moved in distance of 1,200 miles will be equal to $101.41. So that's how you do the multiple regression.